All right, I'm back with a new lesson here. We're going to do more operations with radicals. This time we're going to divide. And when I show you this first problem, and all of them really, at first it might look like there's nothing to do. So the first thing we'll do is talk about that. So here we go. So right off the bat here, you look at this and you go, well, how am I supposed to divide that into that? That doesn't go into that evenly or anything. What do I even do with this problem? So when we're dividing radicals, we're not really in this case dividing radicals. What we're going to do is somebody a long time ago said we don't ever want to leave an answer with a radical in the denominator. That's really, and it really doesn't even say divide, it says simplify. And what it means is we got to get rid of the radical in the denominator. We can have radicals up in the numerator, but we can't leave radicals in the denominator. Why? I don't know. Somebody said so, and that's kind of what we do on this one. This one's a little up for discussion of how important it is, but you certainly see it a lot, so let's talk about it. All right, so let's get right to it. Here's the trick, okay? If I want to get that to no longer be a radical, all I need to do is multiply by the exact same radical. Just I'm pausing, let you think about that for a second. If I were to multiply square root of 5 times the square root of 5, I would just get 5, which would then no longer have a radical in the denominator. But of course we can't just go around doing whatever we want, but if I do this, then it's all legit. I'm allowed to do that. Whenever you want to multiply a fraction by the same numerator and denominator, you're always allowed to do that because anything divided by the same thing equals 1. So we're really just multiplying this by 1. Well, you can multiply anything by 1 because it doesn't change the thing. And so here's what we end up with. We end up with 3 root 5 on the bottom, or on the top, sorry, on the numerator, and the denominator is a 5. Once again, this just is what it is. There it is right there. And then whenever you have the square root of something times the same thing, it just equals that number. Before we do some more, let me give you a little bit of vocabulary. What we just did, generically is called simplifying. We did some stuff. Simplifying is a pretty big term. It just means take something and make it look different, usually nicer. In this case, I don't know, does it really look any nicer? What makes it look nicer is there's no radical in the denominator, once again, okay? And the fancy terminology for that, it's called, we just rationalized the denominator. Sometimes you'll see that as the directions. And they call it that because we're taking the denominator that used to have a radical in it and we're not having it be there anymore. A square root of 5 is called an irrational number because it's a non-repeating weird decimal number. So we're taking something that was irrational and we're now making it a normal number or rational. So we're rationalizing the denominator. We're getting rid of the radical that was in it. Not too big a deal. I mean, it's more important that you know how to do it, but that's the terminology they use for that. Let's do another one. Same concept. We're going to get rid of this square root of 3 on the bottom. We're going to multiply by another square root of 3. So, like that. But once again, we can't just go around doing that unless we do it to the numerator. And then we just do the math. It's going to be the square root of 15 over 3. Done. Going a little faster that time, right? I'll still go back real quick here. This is this times this. Remember when you have two radicals and you're multiplying them together, you just multiply and make one radical. And then whenever these match and they're square roots, then that just becomes that number. If you wanted to go slow on this, you'd say the square root of 3 times the square root of 3 is the square root of 9, but the square root of 9 is 3. Let's do it again. All right, everything just changed. There's two concepts going on in this lesson. What you just saw, which is the simplest, and then a little bit trickier one. Because here's the deal. This now is a binomial, and if I were to multiply the bottom by square root of 3, I'm actually going to do a wrong thing here in the video. Okay, I want to show you. So let's say I use the last directions and I multiplied by square root of 3 right here. Because you see a square root of 3 and you think that's going to get rid of it right there. The problem is you don't just get to hand pick which thing you're multiplying square root of 3 by. If we're going to multiply, in other words, if we're going to multiply the numerator and the denominator by the same thing like that, we are multiplying the whole numerator by that and the whole denominator by this. So I put a parenthesis around it and say times that. The problem is we distribute this now. And so we're just going around in circles because this will now be 3 root 3 plus 3. Yeah, this times this would equal just 3. That's true. But you'd have to hit it with, this one would have to go over here too. And you just have now you have a root over there. Remember, we're trying to have no square roots in the denominator. So this is not the way to do this problem. And I think it would be a challenge to know how to do the problem. I think this is a tricky, the first time you see this, you're probably going to have a little trouble with it. So let's rewrite it. So here it is again. And it's almost like for the first one, you need the trick. And here's the trick. Here it comes right now. Here we go. You're going to multiply by the exact same binomial again, except the opposite sign. Like that. And of course, if you do that to denominator, you got to do the same thing to the numerator. Now you might look at that right now and you're like, well, what's so great about that? Well, let's just do it. Let's see. Well, the numerator, you would just distribute. So you'd have this 3 would go to here, and then the 3 would go to there. So you'd end up with 9 minus 3 root 3. Remember, we can have radicals in the numerator. We're trying to get rid of any square roots in the denominator here. So let's see what the bottom does. We get 3 times 3. This is going to be FOIL. So we have a binomial times a binomial. So we're going to go this times this, which is 9. And then we're going to go this times this, which is minus 3 root 3. Then we're going to go to here, which is plus 3 root 3. And then we're going to go here, this times this, which is minus 3. Explain that again. You got a positive times a negative makes this minus right here. And remember, it's the square root of 3 times the square root of 3. They're the same square root, so that just equals 3. Now look down here and you'll see why this method works. See how this and this are basically the same, but one's negative, one's positive? Or in other words, those are gone. And what do you end up with? Just a number on the denominator, which is that's the job, is to make there no radical in the denominator. So we end up with 9 minus 3 root 3 all over 6. 9 minus 3, 6. And we could probably do a little bit more on this one, but I think we're good for now. I mainly wanted to focus on the idea, which is if you have a binomial as your denominator and there's a radical in it, like this right here, then you're always going to multiply by the exact same binomial, only with the opposite sign. When you do that, it always cancels out these middles, leaving you with just regular old numbers here. Fancy word for this opposite thing, it's called a conjugate. Conjugate is the exact same binomial, but with a different sign than the original. One more. Same concept. We have a binomial in the denominator. We happen to have a radical in the numerator too, but that's fine. It is what it is. So here we go. We're going to go 4 plus root 2. 4 plus root 2. And here we go. Numerator. 4 root 2 plus 2. I can show you that. It's this times this, which is root 2 times 4, or 4 root 2. That looks nicer like that. And then we distribute to here, and we get root 2 times root 2, which is just 2. Now for the denominator. We get 16, 4 times 4. Then we would get plus 4 root 2 minus 4 root 2, and then minus 2. I'll go through that with you. 4 times 4 is 16. This times this is 4 root 2, which is that one right there. Then we come over to here and distribute again. This is negative 4, right? Negative there, 4 root 2, right there. And then a negative times a positive is a negative, and root 2 times root 2 is just 2. If it's the same number inside the square root, then it ends up just that number. And then just like the last one, these go away. That was the whole concept of what we're doing there. We end up with 4 root 2 plus 2 all over 14, which was 16 minus 2. I'm going to go one step further on this one. I wanted to show you how you might see the answers left in the problem. You're always going to get just a number in the denominator like that because you can't have any radicals, so whatever numbers you got left, of course, will combine to make one number. And a lot of times how we'll finish this problem is we'll divide that number into each of these. Once again, I don't know if it's better, worse, same, whatever. It's just how you're going to see them a lot is like this. Okay. So it's going to be 4 root 2 over 14 plus 2 over 14, which equals 2 root 7 over 7 plus 1 over 7. Now that's just me reducing the fractions, right? If I divide each of those by 2, I get 2/7. And if I divide each of those by 2, I get 1/7. That's good enough. You might even see it. It could be written like flipped around too. It could be 1/7 plus 2 root 7 over 7. I didn't do anything there except I just wrote it opposite. I'm just showing you everything you might see. It could be left like this. It could be divided like I did here where the 14 went into each of them. And then a lot of times you'll see the number first, then the radical part. All right, so the lesson, the number one thing you learned is that in algebra class, we don't leave radicals in the denominator of a fraction in any way, shape, or form. You see how now all of our denominators are just regular numbers. It was a regular number here, it's regular numbers here. We don't leave radicals there. And I gave you 2 examples of each. One of them, if it has just a single radical in the denominator, then you just multiply top and bottom by that radical. If it has 2 pieces to it, like you've seen the last 2 examples, then we multiply by what's called the conjugate. Once again, that's the conjugate right here. It's just the exact same binomial. See how it's the same stuff, except I changed the sign. That little magical trick right there always makes these go away, leaving you with no radical in the denominator. Work hard, be nice, see you soon.